Hello everyone, this is Anshika Agrawal and today I am going to discuss on the topic recent advances in food processing and preservation by drying. The topic that I am going to cover here is the basic introduction to drying and dehydration, benefits of drying, factors affecting the rate of drying, mechanism of drying, drying curve, the different types of dryers that has been used in the food industry, and the recent advances or the study that has been done in the field of drying. As we know that food are the complex substances because of their origin, biological origin, which is mainly derived from plant or animal sources. The foods are highly perishable because they contain the high amount of moisture, which makes them susceptible to biochemical reactions and microbial spoilage, thereby requiring the preservation method. Among the common methods that we use for the preserving our food products are minimal processing, refrigeration, smoking, dehydration, or drying. Drying is one of the most old methods and it is used for the reduction of the post-harvest losses in many agricultural produce and improve their commercial value. When we heard the term drying or the dehydration, we mostly think that drying and dehydration is the same process. But no, they are actually the interrelated terms and are used to describe the unit operation which involves the removal of the water by evaporation or sublimation. Drying generally refers to the method of removal of moisture from the food under the natural conditions such as in the presence of sunlight or the windy air, shade, etc. Whereas in the term of dehydration, we use the process of application of the artificial heat under the controlled conditions of temperature, humidity and airflow for the removal of moisture. The different benefits of drying are it eases the handling procedure, reduce the microbial degradation of the food product, reduce the storage cost, packaging cost, transportation cost, and results in the extended shelf life of the food product. The different factors which affect the rate of drying is the particle size, the nature of material, the nature of moisture present in the food material, that is the whether the water is present in the bound form or the unbound form, surface area that has been exposed to the drying procedure, initial and the final moisture content, thickness of the food material, temperature to which it is subjected, nature of the product, and the relative humidity which is present. The basic mechanism of drying is it involves the simultaneous application of heat and removal of water from the food. When hot air is blown over a wet food, the water vapor diffuses through a boundary film of air surrounding the food and is carried away by the moving air. As you can see in the picture in the downside, that how the food material, the way water is coming out of the food product and the solutes are being concentrated. A water vapor pressure, in this way the water vapor pressure gradient is established from the moist interior of the food to the dry air, which provides the driving force for the water removal of the food. The boundary film acts as a barrier to both the heat transfer and the water vapor removal during the drying. Water vapor leaves the surface of the food and increases the humidity of the surrounding, which causes the reduction in the water vapor pressure gradient, which reduces the rate of drying. Therefore, the moving air should be faster to reduce the thickness of boundary film and hence to achieve faster rate of drying. So basically for the drying of moist horticulture produce, the parameters taken into consideration are moderately high bulb temperature. Here the bulb temperature means the ambient air temperature which is present, low relative humidity and the high air velocity. Drying curve. We know at each and every product there is a representative curve which describes the drying characteristic of that product at specific temperature, velocity, pressure condition. And this curve is known as the drying curve for the specified product. Drying basically occurs in the three periods or the phases, like the first phase or the initial phase, second phase which is known as the constant rate period, and the third phase which is known as the falling rate period. that we will discuss with the image in the further slide. First falling rate and the second falling rate, that is D to D and D to D. In the first falling rate, the moisture content in the end of the constant rate period, the critical moisture content, at this point the surface of the solid is no longer saturated and the rate of drying decreases with the decrease in the moisture content. Whereas in the second falling rate, the conditions when the drying rate is largely independent of conditions outside the solid, the moisture transfer may be due to any combination of liquid diffusion, capillary movement and vapor diffusion. Now we will see the different types of drying equipment that we use in the food industry. Basically, the dryers are being divided into the various forms on the basis of the heat transfer mode, that is on the basis of convection, conduction, radiation, dielectric and the combined modes. Convection are the main conduction and the conduction and the convection dryers that we usually study in our UG as well, but the dryers that falls under the radiation, dielectric and the combined modes are the recent advances. As you can see here, this is the direct solar dryer in which the food product is kept and the sunlight is being used for the drying procedure. The next is the tunnel dryer. Here the trucks are being progressed in one direction and the direction of the airflow is in the parallel direction. And the fluidized bed dryer. This is the conveyor dryer in which the food product is moving on the conveyor belt and the air is exhausting with the taking the moisture content with it. Cabinet dryer. Drum dryer that we mostly use in the dairy industry. Here we can make the milk powder from the milk. Spray dryer. It uses the atomizer to make the minute particles. With this also we can make the spray dry powder. Now the question arises, why drying is primarily used for the food preservation and processing? As we know, as the food is produced, before reaching to the consumer, it can lead to various reactions, which can be the chemical reaction, physical deterioration, biological or microbiological deterioration. The preservation of foods by drying is a time-honored and most common method used by humans and the food processing industry, and it is one of the oldest method as well. Why do we need to have the recent advances in the regular drying technique? Because there will be the better quality of the product. It will not pollute our environment. The better process control, the cost economics will be better. It will result in the benefit of hybrid drying. It will save our time and it will give the higher consumer acceptance. The recent advances are here. This is the heat pump drying. As we know, in the conventional dryers, high quality energy such as electricity and fuel is used, which represent a significant amount of low-grade energy that was being lost during this process. In order to reduce this loss, heat pumps were introduced to the system to forecover the latent heat of evaporation of water lost in the exhaust. With the heat pump evaporator placed in the exhaust stream of dryer, the air is cooled and then dehumidified by the refrigerant. The heat added to the refrigerant is then transferred to the air stream, entering the dryer heat pump, thus raising its temperature. The main benefit of dehumidifying the drying air is also realized when the air leaves the dryer and is recirculated, increasing its capacity to achieve the better drying. Next is the microwave drying. Microwave drying is used in food drying in which the microwave penetrates the food material and results in the removal of the moisture content. It has many features like it saves the time, it saves the loss of the electrical energy because it will do the work in the very short duration of the time, and it results in the uniform heating or the drying of the food product. Next is refractance window drying. In this, the circulation water at 95 to 97 degrees Celsius transfers the thermal energy to the material that is being dried. An evenly distributed plastic conveyor belt passes over a hot water through as the pureed products are distributed. When the dried product reaches the cold water section, it hardens. making it easier to separate the belt using a scraper. Ideally, this technology is suitable for products with a distinct aroma and vibrant color that are pureed on the semi-solid. It uses the less time and can result in the high moisture content can be resolved, or we can dry the high moisture content product in a very short duration of time. Next is the radio frequency drying. In this, the heating of food is faster and more efficient because in this we use the internal heat which is being generated in the treated food due to the ionic conductance and dipole rotation of molecules. Hence, the food quality could be preserved by evaporating only the water and heating it only minimally. It reduces frequently used in the final stage of drying to improve the energy efficiency and product stability. Next is the osmotic drying. In this, the food product is placed in the hypertonic solution, which causes a difference in concentration and causes the water content of food to be driven out from the sample to the solution. In the freeze drying, we know that the uh, process of drying a substance through freezing and removal of solvent associated with the direct sublimation, which is the unavailability of liquid water during freezing and low temperature, results in the production of a superior quality end product. Hybrid drying means when we use the different drying techniques. In the superheated stream drying, we dry the product in the absence of air in a medium composed entirely of steam. The ability of superheated stream to dry fruit materials is due to the addition of sensible heat to raise its temperature above the corresponding saturation temperature at a given temperature. So finally the what we can conclude from this presentation is that drying is the oldest method of food processing and preservation. The conventional method of drying is very tedious and it may take a lot of time, and it may result in the product quality which may not be that much acceptable to the consumers. But as per the recent advances, all these problems can be solved, which that is it can decrease the drying time, preserve the valuable food commodity, make the whole process more energy intensive, and reduces the loss that has been done occur during the various drying procedure, which ultimately leads to the qualities improvement of the quality and the extended shelf life of the food product. These are the references.